Hello, everyone, and thank you for joining us for our March 2023 FileMaker STL meetup. I'm Jay Sayers, and my colleague Valentin Vollmer is going to be our presenter today. He's no stranger to our meetup. Super excited for him to share with us what he's got. Let's hash this out, and we're going to talk about encryption and hash and how to use them in FileMaker.
Yeah, it all revolves around hashes, and while some people might not be super familiar with it, there is some neat little functions in FileMaker, and this is less a technical topic, I think, than more of a what can we do with this tool in FileMaker. So I'm going to go through a number of use cases where this little thing called a hash is really powerful. And my expectation, my hope really is that we get to hear other use cases, whether they have been applied already or thoughts and ideas that people come up with during the presentation. I'm just curious about the conversation that I hope we'll all have here. And yeah. With that being said, let me see if I can figure out how to share my screen. Jay, that requires your permission.
Oh, yes, sir. Sorry about that. I thought you would have already had that. Try there.
No. All right. Cool. Let me take this one. Perfect. All right. Feel free to interrupt, ask at any point here. And if Jay, you can keep an eye on the chat because I'm very likely to miss anything, then that'd be awesome. Can you see my screen? You should see a browser with the Claris documentation. Perfect. Yep. All right. So what's a hash? This is the function that this all revolves around. But a hash is essentially an algorithm that takes data, crunches it, and comes out with a unique but shorter string in most cases. So to dive out, can I see a thumbs up? Who's familiar with hashes or digests in this group?
The thumbs up is the reactions button if you guys have that.
Please, yeah, exactly. All right. A good mix.
Even if I were just a little bit familiar with it, yes?
Yeah.
Okay.
Cool. So real quick, I have an example here in my data view. I'm just going to pull this up, and I hope you can see this. What this does is take this text here where it says something, and I'm just going to type my input, and in the result, you'll see this change. And you might notice one thing, that the length of the output doesn't change at all. Hashes are designed that whatever you feed into them, the output is always unique. And that's what we can use in a number of use cases in FileMaker. So let me dive into a few examples a little bit. But before I do that, I want to show you something else that's kind of key to this. The nature of hashes also is that if you give it the same input, the output will always be the same. So it's not like guesswork, or it's like depends like a UUID that depends on local variables or something. If you feed the same text to the same hashing algorithm, the output will reliably be the same. There's a lot of value in there. Don't hashing, however, is not encryption. That's different. And I found this nice little graphic here. So encryption up top is where you take plain text, such as a social security number, and use a key, you encrypt it, and then it is encrypted. However, encryption is a two-way street. With the key, if you have it, you can decrypt this and you get the social security number back as an output. Right here, this is the graph, right? So hashing, however, is different. Hashing is a one-way street. You take text, you put it into the hash function, and it's a hash text. And there is no way to reverse engineer it. That is the nature and the intention of a hash. So they're very different things. Different use cases, both used in the security realm, but in different ways. All right, that's how far I want to go in about the theory. We can dive in a little bit more if we want to later. But I think it's much more interesting how we can use it. So let me get my FileMaker file over here. So I'm going to show you first what we use it for. So we have a scenario where I have server settings where I want to have some settings, my server.com, my username, and my secret password. Oh, yeah, there you go. That's intentional. So let's assume this use case, I enter this here, and I want to run a validation script to make sure this is all correct. I think to some degree, one or another, we've done this kind of stuff before. And I hit my validation button, and it's not actually doing too much behind the scenes. I can show you the script in a second, but let's assume it pinged the API, it connected, it says, yes, you can log in, your username, your password is correct, we are all good to go. So now in our system, we want to make sure that we capture that. And the one thing obviously you can do is like just set a flag and this was validated. However, what happens when something changes? So let's say my secret changed, oops. Then we want to make sure that the validated button gets reset. And here, if I go back and say, oh yeah, I didn't mean to enter this, it was just a typo, maybe it automatically recognized that it was validated, that I moved it back to my previous settings. I did not have to hit the validate button again. And this is a use case where behind the scenes, I'm going to pull in two more fields here. Behind the scenes, I'm using hashes. And that's a real world scenario where we are using it. And let me separate those a little bit. So I'm going to walk through this again on a new record so we can see everything. Right now, and this shouldn't show right now, I just didn't bother with the formatting here. Again, I type in my server, and the moment I commit my record, the current hash automatically calculates. This is an auto enter field that takes these three fields together and generates a hash from it. My secret, every time the information changes, it updates. I'll show you the definition here. My current hash, this is stored and indexed calculation field. And it takes the URL, the username, and the password. And I'm gonna talk about this in a second here, but it just concatenates those three fields together in a text and generates that unique hash from it. So now in my validation script, when I click this button here, I could, here it says, you probably can't see that, it said run some validation. I can connect to a server, do all sorts of good things. And when that all goes through successfully, I set my hash validated to the current hash. And what it does is basically says like, this is what I validated. And it sets it here. This is not a calc field, this is just a regular old field. And it basically is a snapshot of this is what the record looked like when I validated it. If any of these fields change, it's not validated anymore. I can show you this. So I edit this, and you see immediately the current hash changes, this changes. I don't need to go through field level validation. I don't need to track like all the fields before and after, none of that. I can even, and the biggest benefit in my opinion is that the user can change it back And because the hash output is always the same when the input is the same, it goes back to that previous value, and my record will automatically recognize, like, yeah, this one I know, this one I validated, we're good. I don't even need to ping that server again because it was validated in the past. And I find that's often a shortfall of other validation methods when the user makes a mistake and says like, I didn't mean to do that. Then they might have to go through a validation process again, which takes, a few minutes, but it might just be annoying in the middle of the day. So that's one use case where we use this, where you can literally take a snapshot of all the data and have an output, and you can compare it very efficiently to each other. And if I had more fields, I could add so many more fields to my function. I wouldn't have to monitor the before and after values at all. I can just look at the sum. The hash looks at everything all together. And if it's different, I know it's different. If you need to do field level comparison, you can do that afterwards. That's the first use case where we can
Hey, Valentin.
use this kind of stuff. Yeah.
One thing, when you were first explaining this to me, what caught my attention was, and you just said that's what triggered it, was like, you could get a whole bunch of fields, right? We're talking about 3 here. Maybe there are a whole bunch of fields. And my head first went to, well, that could be a lot of data. But then coming back to, yeah, but the hash is always the same length. So even though we might be involving a lot of data to create the hash, it's not going to like create a storage problem necessarily, right? It's not like duplicating
No, I'll show you
all of that data.
I have something prepared for you here. So just real quick, so you know what you're looking at. It's a let function. Here is my input text, the first variable. And this is the digest, is the hash. And the output is the output of the hash, and then the length of the hash, just so that we can see that. So it's 88 characters right now. And I'm going to keep typing in there. And then I am adding the text and even more text. You see that it always stays at 88 characters, which is brilliant, because if you attended our last meetup, it was all about indexes. And how many characters get indexed? Jay?
Are you quizzing me, or are you quizzing the rest that went to the meetup? 100 characters, I think, is what is documented with FileMaker, right?
Exactly. And in the community, a few months back, I encountered that where somebody said, I want to compare this text to that text, and then they used a relationship to do that. But if the text changes after the first 100 characters, it just doesn't work anymore. Like, you can't.
It's not unique.
But if you use the hash, you can literally feed in a text of thousands of characters. Your result is always going to be a unique string of 88 characters for this particular algorithm here. But sorry, Andrew, you had a question.
Yeah, I was just curious. So on the example that you were given, if you put in just on the first line, my server name and secret, does it come up with the same hash? Because it looked like you're just combining the 3 fields.
Yeah, so let's do that. If you're absolutely right. Behind the scenes, I'm concatenating them. So my server name secret.
Yep.
And there you go.
So it does do that. Interesting.
Because in the setup here, and just pulling this up real quick, as you said, I'm just concatenating these, right? I'm not doing anything else to them. So what my algorithm sees is exactly this string.
Okay.
Right?
Well,
yeah, totally. So while we're looking at this, just a little bit, the crypt digest function, the way we have this from FileMaker, I'm going to pull this up here. By default, here it says returns a binary hash, which in our term means container value. So by default, let me duplicate this real quick. Oh no, that's the field definition anyway. I'll go back to my data viewer. can take this one. So I'm just going to strip all this other stuff out. This returns, this is the indicator that this is container data and it can't show it. So this is not exactly what we're looking for in this particular example. So this is why we have to wrap it in this base 64 encoding function. And the 4648, honestly, it just describes which code to use to encrypt it, I think. So if you're ever wondering, it's an example right on this documentation, because it is so common that you actually want to have the text return from this function, that they give you that example right here on the documentation website. All right. And just in terms of terminology, you hear me talking about hashing. That's the hashing algorithm, and the output, so the text that we're looking at here. Oh, something else. The output here, that's called the digest, because that's what was digested by the hashing algorithm. So for the sake of this presentation, I use hash and digest sort of interchangeably here as this output value. All right. Any other comments? All right, let me move on to a different example, because by now I hope the general idea comes to show a little bit where we have this concept of like summarizing a number of possibly like a number of fields or a bunch of text into one string that we can rely on to be always sort of unique. And I'm going to go to my context view here. And another use case is finding duplicates extremely efficiently. So here I have a data set of 50,000 records. This is hosted. And I'm going to switch back and forth here for a moment. I have 2 records for Joyce Morrison, I think. Well, actually, I'm going to open a new window and say, I want to be warned if somebody puts in a record that I already have in the system. I think that's probably use case 1 or 2 of us have encountered. There are different ways to do that. And I'm just going to add one more to your toolbox here. 121. This is a very strange date of birth that this test data produced for me. And I'm going to commit this record. What did I do wrong? No, right here, duplicate. It's just not bright enough for me to immediately notice. So without doing anything, I didn't run a script or anything else, the system immediately searches through these 50,000 records and tells me this is a duplicate. And the way it's doing that is, you see this sort of familiar pattern down here. Like here, side by side, you can see these 2 records. I also exposed the primary key just so that we see they're actually different records. But the hash, again, is the same. And that's a common sort of use case or tool for hashes to be used to identify the same data throughout larger systems. And the way I do this here is I actually have a relationship set up that uses this dup digest, this hash that I create, to see if there's anything else out there. So I have this one here, which takes the first name, the last name, and the date of birth. And obviously you can include so many other things in this string here that you can compare a lot of fields, and you don't have to go through the entire system and loop over fields and find this or use any other methods to identify the duplicate data. All you need to do is have this one stored calc field, which performs on an open record that you're looking at right now. So the performance is the performance impact is virtually non-existent, in my opinion. Be curious to have a conversation there, but it updates as you type, and then it looks across the relationship to an indexed field on the other side. And if there's something to be found, then you can show a warning, or you can react to it in any which way you want. So there's no scripting, no searching, no nothing involved. It's just a simple relationship. Again, here it's a dual predicate relationship because I have to exclude the primary key so it doesn't see itself. It's really fast. Again, you saw that here. It's not a giant data set, but 50,000 records is not nothing either. And it's a super fast way to find that one record that you might have in your system that replicates that same data. There is then more you can do with this because, as I said before, this is super precise. So for example, if I have a lowercase j here, then this obviously would not work because a lowercase character is a difference for this algorithm. However, you can get fancy and wrap your whole calculation in a lower. So if I go back, I'm not going to update my definition right now because I'm not entirely sure how long it takes to update in the background, but I'm going to show you what I meant. So I have the same calculation here. So this is all text that comes in as a literal. If I wrap this, for example, in a simple lower and use that to calculate my hash, then any uppercase or lowercase doesn't matter anymore because all my input is going to be lowercase and I can compare just the values to it. So you can do a lot with the data there as to what you want to compare and how you want to compare it, how you want to catch it, whether it's emails, if you want to do date of birth, if you want to do names or companies, whatever it is, like you could just do that. And again, the idea is that you store it in the moment the data gets entered in an auto enter calc field or in a stored calculation field, because then it's just sitting out there as index data, and it's really fast to use then subsequently in relationships or other contexts to find anything that might be there already. Same deal again, if I change this back, it'll immediately say like, hey, we have a duplicate here and a duplicate there. And again, there's no script running. There's nothing happening in the background. The only thing I'm doing here with this is a show hide condition on this element here that very simply looks at the primary key across the relationship. And if there's no primary key across the relationship, means I'm not seeing anything over there. So if it's empty, then I'm just going to hide my warning, and that's it. So if there is no duplicate, there is nothing to evaluate. There's nothing to see. There's no other record. It doesn't have to dig through thousands and thousands of other records to check whether or not there's a match. It's very straightforward.
Valentin, is there any special consideration like with other characters that aren't alphanumeric, or I see you got slashes for the dates and stuff? Anything you run into there, or can it always create a hash based on basically anything we can put in the field?
Not that I'm aware of,
okay.
Honestly. I want to open this to the group and see if anybody has any experience with that, but it appears to take anything in it. I mean, it's all just ASCII code behind the scenes, and that's what it acts on, right? Or Unicode, depending on what you're using.
One other question I
Don't think
had
so.
was that particular 4648 parameter that you used in your hash mechanism. Is there a reason you picked that number? Is that like a common one?
Yes. So let me jump over to the documentation here. So it's the RFC number. Which standard to use, and honestly, like, I don't know all these, but this is, I probably picked it because they're actually using it straight here in the documentation. but no line breaks added. I think if we use, I wanted one that has no line breaks at the end, because that is confusing, especially if you use it in relationships, right? Because then you have two values. You have an actual value and then a blank line. So these are carriage return and line feed. Same here. I don't know what the difference is between these two, honestly.
And just to clarify, that example that, did I see it here? It might have been higher up on their page. Oh, the SHA 512. So the 4648 is the RFC specification, and then the SHA 512 in this case is an algorithm. Now, you said you had, are there choices of algorithms for FileMaker developers in this case too?
Yes, there are, and here the documentation refers over to a different section. So I'm just going to open that in a new tab here real quick. So these are the algorithms that are available to us to do this. For the sake of this exercise, it almost doesn't matter which one you use. They're all fast, it doesn't matter, because we don't use them in a security-related context here. As I said, hashes and this digest mechanism is sometimes used to store a hash of a password safely, for example. And then when the user logs in, the system then again generates a hash and then compares the two hashes. And the benefit of that is that the clear text password is never stored, it's never processed in the system at all. So even if there's a data leak, the only thing that people will see is hashes, which, as I said in the beginning, are by definition a one-way street. They're not reverse, they cannot be reverse engineered. However, that is only true for the more recent, so probably in this scenario here, probably only for the 512 one. MD5 is not secure anymore. Like, that can be reverse engineered super quickly. That's been hacked and taken apart. Probably the other ones here, SHA-1 and 224 as well. For our context, where it's more about getting data compared, that doesn't matter. Like, we're not trying to hide anything, right? So there are just different considerations when how you use those hashes and what you use them for. It does bring up, however, an interesting point, because not all of us might be on a version of FileMaker that has this available, because I think it was introduced in 16. And we all know we have clients who are stuck on older systems. And the cool thing is that that doesn't matter, because there is always, not always, but for a long time has there been a function that's called container attribute, and that you can use on any old field if you give it. Do we have to quote this one? We do. The option you want to have the MD5 hash of the container field that is not a container field. So that's a native function to get a outdated but still valid hash from the system in older versions of FileMaker.
That's funny. You just said you ran a get container function on a non-container field. Yeah.
Mm-hmm. Exactly right. But yeah, it works. And I've actually used this before 16 in like 15 and 14 environments, and it works just fine. All right. So wanted to look at another use case, and real quick. So sometimes you have scenarios where you need to catch when data changed. I had this where, for example, when there's syncing involved and you want to make sure that if the data got updated, then the latest changes get pushed over to, let's say, a SQL database, or maybe you need to go update a normalized table somewhere, or a non-normalized table somewhere else. There are all sorts of situations where you might want to track whether or not data actually was changed, or just for audit trail purposes. And that's another area where hashes can be really useful. So I'm just going to show this. So we have our same record in this case. I'm just going to change this, and it says, hey, we changed data. That's great. Yeah, so I come in here and I say, I'm going to just change this back. Didn't really change anything. And this one says like, yep, all data is as it was before. What's interesting though is that my timestamp modified updated. And that's where the hashes come in handy, because my timestamp modified updated, however, the data did not change. So I'm going to do this again. Like we are at 8:37:12 seconds. I'm going to modify this record here, but I'm not changing the data at all. And I'm going to commit this now. And it says nothing happened. All data was as it was before, but my timestamp modified updates. So sometimes on big systems, this can be an issue where a record was, for FileMaker, was modified, but the data didn't actually change. And you only want to perform some kind of action when the data really changed. A hash can do that. So right now in my onCommit step and trigger here, I'm just comparing my hash that loaded when I started looking at the record to what the current hash is. And only if that's actually different, I could react to that, whether that's trigger a sync process, do something else. And if nothing actually changed, I can leave it exactly the way it is. I don't need to do anything. I can just completely ignore it. And that might seem trivial in my little example file here, but this can become hugely impactful on larger systems. And one use case that I have encountered is we had a client that imported data, like a lot of data, like tens, hundreds of thousands of rows of data every day. However, the majority of that data was always the same, but they had no way to really identify which was new. And then using hashes on this data, we could identify that only like 10 or 20% of this data actually needed to be updated, and could dramatically reduce the load on the system, because not because we did anything much more fancy, but simply because we only updated the records where the data had actually changed. And we didn't need to compare 10, 15, 25 fields individually. We can just like use that hash that summarizes all these fields into one succinct string. And only if that was different, then we could do a field-to-field comparison and update what we needed to update, and could dramatically reduce the impact of that massive import for the client. So that's something you can do across many areas.
So my understanding, it's kind of like back to your API one, where you had a field that stored the hash before the import, right? Like, here's what exists right now. And after records were imported, something would trigger a different field that would have the same calculation, but you might end up with a different hash there. And so now you can just look for those differences, or a flag that says the two don't match, so something changed.
Yeah, that particular use case was that the import happened into a temp table. So it's a FileMaker table, but like just was not really, it was its own table occurrence, not a ton of indexing going on, just, you know, just get it in there. And then the production table where it needed to go was much more involved. And that table then had downstream impact, even with like additional syncing and that kind of stuff. So it was really sort of a cascading effect where the import into the temp table was cheap, and the only thing we added there was this this hash that didn't really slow down the import significantly at all. But then we could have that one data point, just the way I just demoed the duplication check, and just look at like, hey, did anything change or is everything the same? And again, like if you cut down 80% of 100,000 records, that's a whole lot of stuff you don't have to do anymore, and you don't have to tax the system with. So that was a pretty big impact here. One additional element here on this record that we're looking at, there's the timestamp modified. What a hash configured right would allow you also is to monitor related records, because this is a portal now. When I start typing in this portal, two things happen. My related record, the new one that I created here, is open, but my parent record is also open. So you see that immediately my hash updated as I'm putting in data here, right? And that's because I defined this hash to be calculated, including my related data, and not just the first record, but other related records as well. And I can show you how that works. What's really interesting though is when I commit this record now, so now I have 3 open records. I have the parent record open, I have the 2 child records open. Notice the timestamp modified down here. When I commit this, my script and my hashes say, hey, something changed. And I could react to that. I could say like, okay, I need to do something because something was updated. But because I didn't actually edit the parent record, my timestamp modified did not get updated. But if I look at the data as a group of related data that belongs together, when I say like, I updated records for this contact, for example, this is a way for me to extremely efficiently capture this type of change where some of the built-in functions would fall short. Because another built-in function that you could use to monitor a change is get modified fields. Again, get modified fields only shows you the fields on the current record. It would not show you any fields that were modified on related records. And the way I'm doing this here is that I have another field just for demo purposes that here, this is my crypt digest function, show 512 algorithm, and I'm including lists of my related fields, which makes sure I capture all the related records. So right now I only have the street 1, 2, and the city in there, but of course I can include state and all these other things. And it doesn't matter that they're like completely taken apart for the sake of this. For my purposes here, I don't care if I get all my address line once, then all my address lines 2, then all my cities. It doesn't matter that they're out of order, because for me, it's like, did anything in that sort of group of information change? And then I can react to it and do whatever I need to do, whether it's syncing, updating something, writing an audit log, all this kind of stuff you can do with this. And I don't have to have a fancy script that just loops over all the fields that I just recently changed. The only thing I have to do is compare one stored field to, like in the case of this demo here, a simple string that I load as I'm loading this record.
Couple of questions about that.
Yeah, and I just discovered a bug here, but go ahead.
So the way you had that field set up, I saw that it showed it as it was unstored. Is that right?
It should not be.
Okay.
It should be a stored. Yeah. Oh, because I'm using stored data, huh? Because I'm using related data.
Related data?
Yeah.
Is this a calculation field or is it a text field?
It's a calculation. No, this is a calculation field. And I think in this particular instance, this is okay because this is not a field I would use to dedupe, for example, across a relationship. Okay. This is simply to track the changes while I'm on the record. So this is not something I would do for
dupe detection,
duplicates basically. And this kind of stuff where you need that indexing, right? But
Okay.
in the moment, as I'm entering this field or this record, I'm loading this anyway. So this data is all readily available.
So that's why your modification timestamp didn't change, because it's really just
right.
it's not changing the record's value. It's an unstored calculation that changed in
Yeah.
that
Yeah,
instance.
exactly.
Okay.
Yeah.
But if you were to
And
dedupe something, if you were using it for that purpose, you might put this in a what is it called? Auto enter calc,
Yep.
and actually shove and store that data into that field.
Yeah. The challenge you have with that the auto enter calc is not going to fire if you added a related record only. The auto enter calc will only fire if you added a field locally on the record. So there's a little bit of a challenge to work out, which you can.
But in your
probably
case,
do
you
with
have both, right? So yours could work.
Yeah.
Okay.
Not if I only edit the related data.
Oh, I see. You
Then,
wouldn't see that change in that case.
Yeah. I can show you what I mean. Like,
okay.
So if I create this as an text field with an auto enter calc, then we have the same definition. I definitely want to replace that. Oh, did it?
It probably just needs its first trigger. Oh, did we break your?
I didn't mean
you didn't
to
duplicate.
I meant to duplicate this. Okay. Sorry for this, folks. Change it back to a calculation field. Okay, same calculation. Forgot something again. So this should be, yeah. I'm just gonna move this up top here for a moment. All right, so now this matches, but you'll notice that when I change my related data, only the unstored one will change. Even when I commit the record now, the stored one doesn't change because it doesn't see the related data change. The stored calculation, the auto enter calc, will only fire if I edit a local field, and then it'll recalculate and then they'll match up again. So for the sake of monitoring a local record, I think the unstored calc as you enter in, that's just part of the data that it loads anyway, and gives it to us in a more succinct format that I can then compare rather than try to load every single field in some kind of variable in JSON. And then when I commit it, I loop over every single field and see if anything of that changed. I can do this very, very efficiently. So I want to leave a few minutes open here before we hit the top of the hour. But it's, in my opinion, it's a neat little tool to keep in the tool bag that comes in handy in certain use cases. And I hope I was able to show some of them here. And maybe I'd be curious to hear if anybody has worked with that or has a use case where they think they could apply this, or any other thoughts here towards the end of that meeting.
I had a quick question about the crypt digest function.
Yeah.
Real quick. I'm not seeing any limitation on what kind of field types could be used to encrypt, to create that hash. Have you ever experimented using like a PDF, Word document, any other type of file types?
In fact, I'm pretty sure that that's one frequent use case, to get a hash of a binary file, like a PDF or a Word document, and monitor whether or not that changed. You'll see that actually a lot when you download files. The site you download is from like, hey, this is a SHA or MD5 hash for this file, is this and this. And if you then download that file, you can regenerate the same hash, because remember what I said in the beginning, if you provide the same input, use the same algorithm, the output is the same. So you can then take your hash from your local computer, compare it to what the website said it should be. And if it's the same, you can be sure that the file wasn't monkeyed with. Yeah, there was no man in the middle attack or something. It's like actually the file that you wanted to download. So it's a frequent use case. So I'm very sure. And again, like this is originally the get container attribute. Don't have it here anymore. Like that's a hash for a container field originally that you can just also use on other things. But this should work 100% on container fields / files. So you can, yes, if the question is, if the client provides you every day with an Excel spreadsheet, and you want to determine whether anything changed in that spreadsheet, and you run a hash on it, you could do that. Just remember that metadata in a file can also change. So if it's regenerated every day, then it's going to be a different hash, even though the same data is in the table, but some metadata in the file probably changed, which would result in it having a different hash. But if the file literally wasn't touched from one day to another, then you would come up with the same hash, and you could confidently say, it's like, nothing changed in that file. I'm not running an import.
Jeremy raised his hand. Is that true, Jeremy?
I did.
Cool. What do you got?
I was trying to think of how this might work. But I wonder if you had a situation where it was a really common use case for a user to have to search across multiple fields, and maybe those fields were a combination of stored or unstored, and it was just really taxing for FileMaker to have to search across all of those fields all the time. You know, like they're looking for, you know, I don't know. There's just, you know, you can envision the situation, searching across a bunch of different fields, and maybe you could reduce the load on FileMaker if you had those fields that you knew were going to be hit a lot in a find like that. If you had a hashed value that was tied to each of those fields, and then some kind of scripted find. So when they actually performed their find, FileMaker was only having to search against one indexed field, which was the hash, instead of however many other fields they were actually trying to search in.
Like let's take the dedupe example that I had here earlier, right? Where if the user was to put in exactly the same sequence of data, then I can combine these three fields into one, because then what the user inputs would generate the same hash than what I concatenate here. But it would literally have to be the exact same.
Right.
So that's
yeah. I mean, I guess functionally it's very similar to your dedupe thing. You have multiple fields, and you're able to really quickly compare those three fields for an exact match. So you could kind of reverse engineer that into some kind of scripted find where you were looking for three exact values in these fields, and you could really quickly maybe I don't know, like someone who understands under the hood of FileMaker better than me, but maybe you could find it faster by searching in the index hash field instead of those three fields.
I'm not sure how it would hold up performance wise. My first reaction is like, because hashes are so precise, I'd be worried that you encounter more limitations than benefits. Unless, I mean, keep in mind, you can, like if they want to say, I showed a little bit of that earlier when I said, like, you can modify the hash slightly with, like, you know, with the lower function, for example. So then it's like case insensitive, the whole thing, because you store the hash and you feed it in with lower. You could then go even further and say, like, if they often just use, you want to restrict the input to 3 characters, you can then go like left 3 of the first name, left 3 of the last name, and you can play with all these other text parsing functions to generate your hash initially, and then use the same for when the user puts in their search. So I think it really comes down to the very specific use case, whether or not this is useful or overkill or an obstacle.
I think that's super exciting. So we talked about some deduping record techniques, and like what would you call that? Little notifications or indicators that something has changed types of techniques as well.
Yeah,
And the
like
difference
data
between.
monitoring.
Do you think that demo file that you had, Valentin, is good enough to share with the group? Just so they had things like, oh, here's a calculation example. Didn't quite catch that as you were running through it. Was looking forward to dissecting that a little
Yeah,
bit more.
there's nothing fancy in here, so it's not something I would put on a blog or something. But
Right.
this file also has nothing proprietary in it. So yeah, we can absolutely share this. And
Right.
I think what I want to send people home with is, like, again, I said that up front, this is not a technical challenge. Generating the hash is really straightforward. This is more like a conceptual thing. Like, keep that in mind in your toolbox, and you will come across use cases. Like, I keep finding new use cases, and sometimes it takes a year to find a new one, and then go like, oh my gosh, I have to use this because it's really fast.
Please take a look at our Meetup website. We've already got an event out there for next month. We have Todd Geist presenting Auto. Todd Geist says that he's even going to share some exciting upcoming features during that meetup. So that's next month, April 18th, same place. Hope you can join us.